Question. How is work calculated? What's the metric unit for work? What is the difference between actual and ideal mechanical advantage? What is efficiency? What are the 6 simple machines and how do they make work easier? Words to know. Work, friction, mechanical advantage, actual mechanical advantage, ideal mechanical advantage, efficiency, complex compound machine, screw, wheel and axle, lever, inclined plane, pulley, wedge, joule, input force, output force, load. How is work calculated? What is the metric unit for work? Well, work is done on an object when a force moves it some distance. And the force you exert must also be in the direction of the object's motion. If there is no motion, no work is done. So this guy in this picture, no matter how much he pushes, if that wall doesn't move, he is doing no work. In the equation, work equals force times distance. If there is a distance of 0, doesn't matter how big the force is, work will still be 0. And the metric unit for work is the joule, and that is equal to 1 Newton meter. Let's try some practice problems. A box is moved 5 meters with 5 newtons of force. What is the work done? Let's take a look. We can put in work equals force multiplied by the distance. Our force is 5 newtons. And we're going to multiply that by 5 meters. And that gives us 25 joules. We abbreviate joule with a J. And that's how you calculate work. Try this one on your own. A rock is pushed 10 meters with 4 newtons of force. What is the work done on the rock? What is the difference between actual and ideal mechanical advantage? Well, a machine is a device that makes work easier. The machine makes work easier by changing the amount of force exerted, the distance that force is exerted over, or the direction of force. But the overall work will remain the same. And that's what a machine does. But what exactly is mechanical advantage? Well, a mechanical advantage tells you the number of times that input force is multiplied by a machine. So the greater the mechanical advantage, the less input force that is needed to do the same amount of work. So if we want to get something to be lifted up a certain distance from the ground, we would need to exert some force and move it some distance. But that amount of force could be less if we use a machine. Now, the ideal mechanical advantage is when there is no friction. But actual advantage, mechanical advantage, is what you get in real life where there's always friction. Some energy, some of that work is always used up as heat. It's released as heat, and that's caused by friction. So what is efficiency? Well, efficiency is that percent of input work that is converted to output work. An ideal machine with no friction would be 100% efficient. That is never the case. Machines aren't perfect, and some of that work that you want to do is always going to be used to overcome friction, and you're going to lose it as heat. But we can increase efficiency by keeping the machine clean and lubricated, like oil or grease. So what are the 6 simple machines and how do they make work easier? Well, the 6 simple machines are the lever, wheel and axle, pulley, inclined plane, wedge, and screw. The machine makes work easier by changing that amount of force or the distance of force or the direction of the force. The lever can change the amount of force. It can also change the direction of the force. For instance, we can push down here, and we'll be lifting this load up. That is changing the direction of our force. Also, if we adjust the fulcrum, we can then reduce the amount of force, the input force needed here, but we will in exchange have a greater distance that we have to have that input force travel. But it's a lot easier to lift this load.
Pliers are a form of lever. If we look at some pliers, we can see that our input force is here, but our load would be at the end where they come together and the fulcrum's in the middle. So these can be considered levers.
Wheel and axle is actually part lever. We can think of this axle here as being a fulcrum, and the wheel here is that effort arm around it. A doorknob is an example of a wheel and axle.
A screwdriver is an example of a wheel and axle. How is that? Well, we have the axle is the skinny part. The wheel is the larger part that you hold. And the larger this area is here, where we hold it, the greater mechanical advantage we'll have. Imagine trying to use a screwdriver with just the skinny metal part. It'd be very difficult.
The pulley is another simple machine, and there are different types of pulleys. The main two kinds are the fixed pulley and a movable pulley. This is a fixed pulley here, and you notice it can change the direction of the force. We can pull down to lift something up instead of having just lift up on it to lift it. And we know the mechanical advantage of a pulley by the number of supporting strands. Here we only have one. Here we have 1, 2. And over here we have 1, 2, 3, 4 supporting strands. And that's the mechanical advantage. That's how many times that effort force is multiplied by, or how much lighter this load becomes.
Window blinds are a great example of a pulley. When I pull down on the string, the blind goes up.
The inclined plane, also called a ramp, is in many places, including stairs, hillsides, switchbacks, and roads. Those are all examples of an inclined plane, and the mechanical advantage can be calculated by taking that distance of the ramp and divide it by the height of the ramp. Wedges are two inclined planes put together. Also, it is a moving inclined plane.
Anything with a sharp edge or a point can be considered a wedge. Here on these wire snips, we have some sharp edges. That's a wedge. Even a point of a nail, that's a wedge. And the blade of this X-Acto knife, this also is a wedge. A wedge can be two inclined planes put together or just a moving inclined plane.
There are various kinds of throughs. There are various kinds of screws in the world, and those are all simple machines. And the more threads there are, the greater the mechanical advantage.
Screws and drill bits are examples of the simple machine of a screw. You can see the lines showing the threads. And the closer the threads are together, the greater the mechanical advantage. You ever read those I Spy books and then look into your junk drawer and wonder if you could spy anything? Well, what simple machines can you spy in this drawer?